Welcome to General Chemistry 1 Self-Learning Module number 18. This module is about theoretical yield and percentage yield. After going through this module, you are expected to 1. Explain the concepts of percent yield and theoretical yield. 2. Derive the theoretical yield for a reaction. 3. Calculate percent yield of that reaction. And 4. Appreciate the essence of percent yield production of products. Let us check your background about the lesson. Take the pretest. Choose the letter of the best answer. Number 1. This refers to the maximum amount of product that can be obtained from a given amount of reactants in a reaction. A. Theoretical yield. B. Percentage yield. C. Stoichiometric factor. Or D. Limiting reagent. The answer is letter A. Theoretical yield. Number 2. In reality, the actual yield of a reaction is blank, the theoretical yield. A equal to, B less than, C greater than, or D more than. Letter B is the answer. Number 3. This determines how efficient a particular reaction is in terms of the production of a compound. A. Theoretical yield. B. Actual yield. C. Percentage yield. Or D. Stoichiometric field. The answer is letter C. Did you get it right? Let's move on to number 4. Number 4. Which of the following does not contribute in lessening the actual yield of the reaction? A. Side reactions. B. Separation techniques. C. Incomplete reaction. Or D. Unequal moles of reactants. The answer is letter D. What is the percent yield of a particular reaction with an actual yield of 78.2 grams and a theoretical yield of 93.8 grams? A. 38.7, B. 83.4, C. 83.7, or D. 38.4. The answer is letter B. Before the lesson, let us recall the concepts that you have learned in your previous self-learning modules. You have to identify the terms that is being described by these statements. 1. This type of reactant is completely consumed in the reaction to form the target product. 2. This type of reactant is usually present in greater amount to ensure that the other reactant is completely reacted. 3. In the industry, this type of reactant is usually maximized to be consumed due to its expensive price and less availability. 4. This substance is left unused at the end of the reaction. 5. This type of reactant dictates the amount that could be produced in a particular reaction. And here are the answers. You will use your concepts of the limiting reactant and the excess reactant in our lesson for today, which is about theoretical yield and percentage yield. What is a percentage yield? It describes the ratio of the actual yield to the theoretical yield. So to get the percent yield that is equal to actual yield divided by theoretical yield times 100. The actual yield is what the experimenter collects after doing an experiment. On the other hand, the amount of limiting reagent present before the start of a specific reaction determines the so-called theoretical yield of the reaction. Keep in mind that it is the maximum obtainable amount of yield based on the balance equation of the reaction. Let us try to use the formula by applying it in the following sample problems. Sample problem number 1. Ammonia is produced by reacting nitrogen gas with hydrogen gas. Calculate the percent yield if only 54.0 grams of ammonia were produced and the theoretical yield is 78.0 grams. The solution is you need to plug in the values of the theoretical and the actual yield on the equation and perform the needed operations. The given actual yield is 54.0 grams and the given theoretical yield is 78.0 grams. If you divide them and multiply the quotient by 100, then you will get 69.2%. Sample problem number 2. Study the given reaction. In an experiment involving the production of aspirin, 20.9 grams of salicylic acid is reacted with excess of acetic anhydride. Upon completion of the reaction, 10.38 grams of aspirin is produced. Determine the percentage yield of the reaction. Our solution is, since acetic anhydride is in excess in the reaction, therefore salicylic acid is the limiting reagent. Our goal is to determine the theoretical yield of the reaction, but before that, we must start from the given mass of salicylic acid. We need to determine the moles of salicylic acid from the given mass with the help of the molar mass of salicylic acid, which is 138.1 grams per mole. So 20.9 grams of salicylic acid multiplied by its molar mass will give you 0.151 moles of salicylic acid. The next step is to calculate the moles of aspirin produced using the calculated moles of salicylic acid via stoichiometric calculation from the balance reaction. 0.151 mole of salicylic acid multiplied by its mole ratio with aspirin, which is 1:1, will give you 0.151 mole of aspirin. The maximum amount of aspirin that can be produced is 0.151 mole. Therefore, the theoretical yield is 0.151 mole. Next, since the mass of the actual yield is expressed in grams, we need to convert these moles into grams also using its molar mass. 0.151 mole of aspirin times its molar mass, which is 180.2 grams, will give you 27.2 grams of aspirin. Lastly, we could calculate the percentage yield by plugging the values of the theoretical yield and the actual yield in the formula. The given actual yield is 10.38 grams and the calculated theoretical yield is 27.2 grams. Dividing it and multiplying its quotient by 100 will give you 38.2%. Sample problem number 3. Methyl salicylate, commonly used for temporary relief of muscle or joint pain, caused by strain